Welcome to my video series. This is a series of videos that I am making, which my son Abhirath can watch it whenever he is ready. So today you can see that this is a A4 size paper. Most of us will be using this in general writing and printing, but we are not aware of the interesting features of this paper. So we'll be covering this today. So this is a A4 sheet of paper, which most of us would have used it for printing at some time or other. But what we are not aware of is that it is part of an interesting series called as A series of papers. So you could say that it's part of a series where it is A4, A3, A2, A1 and A0. And the standards for this are defined in ISO 216. So you can read it up on internet. Though the specifications are clear, I would like to concentrate on three things which I consider basic for defining this standard based on the usefulness. The first one is the area of A0 sheet is 1 square meter. So think of it like a unit square of 1 meter side. So the A0 area has to be like 1 meter square. The second one is irrespective of whichever number or whichever the paper it is, the ratio of the two sides always has to remain same. So that is ratio is a constant. And the third one is that whenever you go from one lower series to the higher series, that is from A0 to A1, the area should be half of the higher one. So basically the area of A1 should be equal to half of the area of A0. So these are like the primary standards that are there in A paper series. So now based on this, like we will try to figure out a few more interesting things. And though we don't know like what is the exact ratio of these sides, we will try to see if there is some easy way of figuring that out. And since A4 is the most frequently used one, we will also see like how we can use it for like general understanding of other concepts. So by this logic, let us say if we break this A4 sheet into two sheets, you should basically get a A5 sheet. So now we know that this is A4. Let us just break it into two parts now. So now once we convert this A4 into two equal halves, so the area will be the same, and then we can say that each of these sides is an A5 sheet of paper. And we will stick to some standards. At any size, the longest length we will be calling it as the base, and the smaller side we will be calling it as height. So since this is, if you consider this as an A4 size, so we would call this as B4 for base 4, and we would call this as H4 for the height 4. And similarly, when we break it down further, we will call it as B5 and H5. So now that sheet would become this one, where you have the larger side is called as B4 and the smaller side is called as H4. And we will also draw a diagonal. We will do this diagonal by connecting the opposite sides of this rectangle. And we will also call it as D. And since it is A4, we will call it as D4. So now once we fold the paper into two halves, you would be getting something similar to this. And to keep our standards, so we will rotate this so that like this is the longest side is on the bottom. So this would become your B5 and this would become your H5 and this would become your D5. And then based on the standards, and since we folded the same thing, we also know that the ratios has to be constant. But one way of identifying that is you create a diagonal and you see that the sides are parallel to each other. So now let us say, let me take out this sheet. So these are the two sides. So the sides are 90 degrees for a rectangle and they are parallel. And when we connect the diagonals, you see that diagonal can smooth through this, which also means that these two rectangles are similar rectangles. And also by our logic, we know that the area of the smaller, that is like A5 series, has to be half of the area of the A4 series. So which also means that at this point, if you consider this one, you can say that like this area, the smaller rectangle, if you double the area, you would be getting this bigger rectangle. So now we know that like this is part of the series and this is A5. Now let us try to look at like what is going to be the ratio of the base and the height. And as we discussed, base is the higher side. So we'll do one thing saying that the ratio has to be same, which means that B4 by H4. B4 by H4 has to be same as B5 by H5. And we also like converted this here. So now let us see B4 and H4 is here, and we have the B5 here. And when we open this up, we see that B5 is equal to H4. So this is equal to B5 is equal to H4. And let us look at H5. So this is your H5, and we know that this is half of the base of H4. So this is basically your total B4, and this is your B4 by 2, B4 by 2, and this H5 is now equal to B4 by 2. So let's write it as B4 by 2, B4 by 2. And when you cross multiply, you basically get B4 square by 2 is equal to H4 square. And the ratio that we want is base by height. So if we say B4 by H4 whole square, that is equal to 2. So we have B4 is equal to root 2 times H4. And this is going to be the same for all the different sizes. So if you consider B5 is equal to root 2 times H5. So by this logic, so this is your H4, this is B4, and this is your D4. So now we know that base is root 2 times. So now if you consider this as 1, this will be your root 2, and this will be your root 3 by the logic of, by using Pythagoras theorem. Square root of a square plus b square, that is going to be square root of 1 plus 2. So this is going to be square root of 3. So by this logic, we can also call it as roots triangle or the root square, which will make it easier for us to understand the ratios between the two things. And also, like initially, like we had seen that A4 is half the size of A3 and so on. And for A0, we know that like it's going to be 1 meter square. This is the total area. So this is like an exponential series. So 1 by 2, 1 by 2. So now like whenever we look at like A4, right? So we know that half, which is like half to the power 4. So by that logic, we can also say that if you have A4, 16 A4 sheets together will have the same area as a A0, which is basically your 1 meter square. So we can say that
AN.
If you take an sheet and then basically like 2 power n such sheets, if you put it together, you will be getting A0, which is nothing but equal to 1 meter square as well. So now let us say that like we want to figure out the sides of A4. So by this logic, we can also get that area of A4 is equal to 1 divided by 2 power 4, which is nothing but is 1 divided by 16. That is going to be the area of A4. And we also know that the ratio of base to the height is also 1:2 square root 2. So now if we say B4 divided by H4, the area of A4 paper is going to be B4 into H4. For B4, we know that it is root 2 times H4. So root 2 H4 square is equal to 1 by 16. So that also gives us H4 is equal to square root of 1 divided by 16 and root 2. So this is going to be 1 divided by 4 and 4th power of 2. If you do these calculations, you would be getting the H4 is equal to 0.211, which is very close to the standards defined in the A4. So the sizes of A4 is going to be 21, or like let's put it in millimeters, that is 210 millimeters. The height is going to be 210 millimeter, and the breadth is going to be
297 millimeters.
So without knowing these numbers, just by based on these rules, we were able to get this area. Thank you. For more such videos, you can visit learningpaths.io, patinga.in, or for more detailed text instructions, you can look at gokulnk.com. Thank you.